let's get some hands-on. We're going to first interact with our IP configuration. If you look at this screen here, what you're going to see is IP configuration. In that IP configuration is the IP is taken from a computer. And I'm going to show you how to do that. First thing you do, you pop up, right? CMD. On your Windows computer, you search for CMD and you're going to open this command prompt. And in this command prompt, you can give the command IP config. If you hit enter here, what you're going to see will be the IP configuration of your local device. This IP configuration will tell you a few things about this device. It tells you here how you're connected to the network. Right over here, it says Ethernet adapter 8. That means my device has an Ethernet adapter, but it is disconnected. You have this wireless LAN 2. It's disconnected. You have this wireless LAN 1 disconnected. Ethernet adapter 5, all of these are disconnected, but you have one that is connected. It is this one, wireless LAN adapter Wi-Fi. The connection DNS suffix, that's really the name of the device where the IP configuration came from. There is IPv6, we're not going to touch on that now, but we will learn about that much later. We want to focus on IPv4 address. Look at the IPv4 address. It has a few different components that are very important. The first component is the IP address itself. Number two, you have a subnet mask. And the third component is the gateway, the default gateway. Because you have an IPv6 address here, you have a gateway for the IPv6, and you also have a gateway for the IPv4. The difference between the IPv6 and the IPv4 is the number of bits that they have. The IPv4 has 32 bits. You may not understand what that means now, but you will understand. Each one of these numbers that is separated by a dot, right, is called an octet. And the octet stands for 8 digits. Although you see 2 digits here, really this number is written with 8 digits. It is converted in human number system for you. This is the decimal number system. That's why you see 10. But originally it came from another number system that's called the binary number system. We're going to learn about the binary number system. So 10 is an octet, that's the first. 0 is another octet, that's the second. 0 is the third octet, and 160 is the fourth octet. So these 4 octets, because each one of them is made with 8 digits or 8 bits in binary, then if you were to multiply 4 by 8, it would be 32. That's why they say the IPv4 is a 32-bit address. The same thing is for the subnet mask as well. The default gateway as well is written in binary, in decimal notation as well, or dotted notation. That's the dotted notation means that it's written in decimal, and then it has a dot between each octet. But understand that that's not the only way you can write an IP address, an IPv4 address that is. An IPv4 address can be written in the dotted decimal notation, which is what we see here. It's a decimal number system, the type of number that we understand, 1, 2, 3, 4, 5, 6, 7. And it has a dot between each octet. It could also have been written in binary notation, in which case it would have been a much longer number because it would have 32 digits in total. We will learn about how to do that. But for now, let's be satisfied with knowing that we have an IPv4 address. That is a good thing for you to communicate on the network. You've got to meet this condition, number one. Number two, you have a subnet mask. The IPv4 address is the address of my device on that network. If any device wants to communicate with my device, then they need to reach out to this address because that's the address that represents my device on the network. Now, the subnet mask represents the whole network. It tells how big this network is. Okay? And we're going to learn about how big this network is very soon as we see the subnet mask. This right there, it tells me exactly how many other devices can be connected to this network. The gateway is the IP address of the closest router to me. So if I need to go and communicate with another network, I need to send my traffic to this gateway, which is the IP address of my router, the router that is closest to me, the router that services my network. And this router will now be able to forward my traffic to the external network that I need to communicate with. Think about if I need to go to Amazon.com again, then I need to forward my traffic to this gateway. And this gateway will now forward my traffic for me to the next gateway in line, and the next gateway in line, and the next gateway in line, and the next gateway in line until it gets to Amazon.com. That's how the internet works. One router forwards to the next router, forwards to the next router, and forwards to the next router until it gets to the destination. Now, there are ways for you to understand those different hops that the traffic takes before it gets to its destination. To do that, you can do a trace. You can do a trace, and the command for that is trace cert. And you can put Amazon.com. And that's going to tell me these are the different routers that I go through from my house to Amazon.com. And you can see the first router is my own default gateway. The second router is a public IP address. I know it's a public IP address because I know what a public IP address looks like. You're going to learn that too very soon. And then there's a third, there's a fourth, there's a fifth, and it goes on and on and on until it reaches Amazon's network. It's going to continue, and it's going to tell me every single router, so long as the router allows for people to know its IP address and to see that in an output like this. That's it for now, how to interact with your IPv4 configuration and the different parts of the IPv4 and their importance. Now, if you want a Mac, there's another way to find that, but I recommend that you use a PC for this class because it will be a whole lot easier for you to configure networks.